Okay, students. So we have started this chapter. Okay, I'm sorry. We have started this chapter, thermal properties of matter. No, Zen, you should not leave beta because today I will start the thermal properties of matter, basically basic properties. So that topic is not related to the previous one, so you can easily study. Okay. So now, students, we will discuss the basic thermal properties of matter. Okay. So what are the basic thermal properties? As I told you yesterday, boiling and condensation, melting and solidification, and the next is evaporation. All right. So these are the properties. Okay. When the solid will absorb the heat energy, it will be converted into the liquid, which is called melting. Assalamu alaikum, Zuresh. All right, and when the liquid will lose the heat energy, so it will be converted into solid. Okay. Similarly, beta, when the liquid will absorb heat energy, it will be converted into gas. And this process is called boiling and evaporation. Okay. And when the gas is converted back into the liquid, so this process is called condensation. Okay. And in this process, the gas will lose the heat energy. Now, students, we will start with this topic today, that is melting and solidification. Okay, melting and solidification. Right heading in your register, students, melting and solidification. So, what is the definition of melting? Melting is the change of state from a solid to liquid without change in temperature. Okay, melting is the change of state from solid to a liquid without change in temperature. Now, this is the interesting thing, student, that temperature is not changing and still the solid is melting. So, basically, temperature is not changing means, students, that temperature is changing during the melting process. All right, during this transition state, the solid will be converted into the liquid state, but during melting, the temperature will not change. Okay, so this definition is important, Vida. You can write down the definition. Melting is the process or change of state from solid to liquid without change in temperature. All right, and how can we define solidification or freezing? Solidification is the change of state from liquid to solid. Okay? From liquid to solid without changing temperature. Alright? So it means that during melting and during solidification, temperature will not change. Okay? Temperature will remain same. So now you can see, beta, when the solid will absorb heat energy, it will be converted into liquid. All right, so this process is melting and okay, and when the liquid is converting back into the solid, so it means it will lose the heat energy. So this process is called solidification. And during these two processes, beta, the temperature will remain same, temperature will not change. Is it clear to you, everyone? Okay, now let me show you one more slide, students. You can see, beta, in this slide, all right, melting and solidification. Okay, this is the diagram. You can see melting occurs at constant temperature. Okay, melting occurs at constant temperature. All right, it means that the students during melting, temperature will not change, it will remain same. So you can see these are the solid molecules when they will absorb the heat energy, so they will be converted into the liquid state. But remember, student, during the change of state, there is no change in temperature. So how it is possible that if the solid is converting into liquid, but still the temperature is not changing? So now you can understand this phenomena with the help of this diagram. Okay. So this question is important, beta. It will be asked in your exam. What happens when solid melt? This question will be asked in theory paper of 3 marks. I'm repeating, beta. This question will be asked in theory paper of 3 marks. What happens when solid melt? So now you can see, students, melting occurs when the solid is heated. Obviously, you can see right now these are the atoms of solid. They are closely packed together. So when we will supply heat energy to the solid, so the solid atom will start to vibrate on their mean position. Obviously, after gaining the heat energy, they will start to vibrate, all right, and they will move here and there rapidly. All right, so it means that their kinetic energy is increasing. Basically, the heat energy which the solid is absorbing, this heat energy is converting into kinetic energy because the molecule will start to vibrate. Okay, so now you can see the particle will start to vibrate faster about their fixed position. Okay, so when they are continuously vibrating, the temperature of the solid will increase. Okay, because the solid molecules are absorbing heat energy, so you can see the temperature is increased. But still the solid is not converted into the liquid state. It is in the solid form. Okay, so now you can see with a solid atom will have a strong force of attraction. Okay, solid molecules have a strong force of attraction and they are continuously absorbing the heat energy as well. So when the temperature is high enough so that the solid molecules force of attraction can be overcome by the temperature or can be overcome by the energy supplied to that solid. So now the force of attraction or bond between the solid molecule will start to break. All right. Basically now, initially the solid particles are tightly packed to each other. They are tightly packed to each other. And we are supplying heat energy to the solid molecules. So still they are vibrating, but they are not converted into the liquid. बेसिकली हमने ये परसेप्शन बनाया हुआ है कि हम सॉलिड को हीट करेंगे वो लिक्विड बन गया, ऐसा नहीं है. ऑब्वियसली द सॉलिड इज एब्जॉर्बिंग हीट एनर्जी. कब तक एब्जॉर्ब करते रहेगा? जब तक वो मेल्टिंग पॉइंट पे रीच नहीं करेगा. ठीक है, so it means that the solid is continuously absorbing the heat energy till it will reach the melting point. ठीक है, so now you can see after absorbing the heat energy, these atoms will start to vibrate vigorously. They are moving rapidly. All right, and the force of attraction between these solid molecules will start to become weaker. All right, the force of attraction between these solid molecules will start to become weaker. So when this vibration vibrate कर रहा है तो force of attraction weaker होगी. When the vibration is high enough, when the temperature is high enough so that the force of attraction between these molecules will become weakest, and now the atoms are moving away from each other. देखें, these solid atoms are tightly packed just because of the force of attraction between these atoms. But after absorbing heat energy, when after absorbing heat energy, force of attraction become weaker. If the attraction or bond between them will become weaker, so now they can move away from each other. And when they are away from each other, so it means that they will not be in the solid state, they will be converted into the liquid state. So during this transition, beta, during this transition, देखिए, initially the solid is absorbing heat energy. Initially it is absorbing. But as the force of attraction will break down, so it means the solid is converted into the liquid state. Clear, student, that what will happen when the solid is converted into liquid? Assalamu alaikum, Shameen, Aiza. We are discussing the process of melting. Okay. So
Walaikum assalam, ma'am.
this question is very important, beta. It will be asked of 3 marks, so you have to write the enough explanation for 3 marks if it will be asked in theory paper that what happens when solid melt. Okay. So now today, beta, we will discuss one experiment. You can see this animation. These are the solid atoms. They are absorbing heat energy, and after absorbing heat energy, their force of attraction will become weaker and the solid is converted into liquid. Now the liquid is absorbing heat energy, so it will be converted into gases which have greatest kinetic energy. Okay. All right. You can see this animation again, beta. solid atom is absorbing heat energy. They will start to vibrate and it will be converted into liquid. You can see as the solid is converting into the liquid, bonds are breaking. Bonds are breaking and the force of attraction become weaker. Now student, we will learn one experiment today, and I'm telling you beta, this experiment is very, very important. These types of experiment usually come in ATP, or if it will come in theory paper, so mostly their graph or observations can be asked. Okay, so you can write heading in your register. This is experiment number 2. Yesterday we have done one experiment number 1 to determine the specific heat capacity of solids. Now we are doing, students, experiment number 2, that is to determine the melting point of ice. We have to determine the melting point of ice, at what temperature the ice will melt. So you can write the objective of this experiment in your register, beta. Determine the melting point of ice. Okay, so we are performing one experiment right now. So it means obviously we require some apparatus as well to conduct this experiment. Assalamu alaikum, Zarlish. All right. So this is the experiment. I am repeating, students, to determine the melting point of ice. Okay. So what are the apparatus we will need to perform this experiment? You can see these are the apparatus. Okay. So what are the apparatus? You can see this is retort stand. All right. Thermometer, beaker, crush ice. We are using crush ice instead of block ice. I will tell you the reason behind it, that why we are using a crush ice. Tripod stand, burner, all right. And one more thing which we will need here is stopwatch, which is not mentioned in this diagram, stopwatch. Okay. So these are the apparatus which we will use to perform the experiment. And in this experiment, what we are doing, beta, we are basically finding the melting point of ice. Okay. So what we will do, students, initially we will take the ice, we will crush it. We will take the crush ice. Obviously, during crushing, the ice will start to melt. Okay. We will take the crush ice and we will put it into the beaker. Okay. And we will immerse the thermometer into the crushed ice and we will record the initial temperature of crushed ice. It will be around -17 डिग्री सेल्सियस. ठीक है, जब हम फ्रीजर से कोई चीज़ निकालते हैं आइस स्पेशली, तो उसका टेम्परेचर -17 डिग्री सेल्सियस होता है. तो बेसिकली द क्रश आइस टेम्परेचर इज -17 डिग्री सेल्सियस. ओके, so we will record the initial temperature. Okay, and after recording the initial temperature, exactly, Naya. Acha, basically we are using crush ice here because crush ice can make a greater contact with the thermometer as compared to the block ice. So the thermometer can record its temperature accurately. Like for example, if I'm using the block ice, so block ice must be in this pattern. So if I insert the thermometer, so might be possible that the thermometer is not completely making contact with the ice. Okay. So that's why crush ice is used to make a greater contact with the thermometer. So it will give us more accurate reading. Acha, thermometer should be immersed 1/3 into the beaker. Okay. Thermometer should not be fully immersed, beta. Thermometer should be immersed 1/3 into the beaker. What is the reason? If we will immerse the thermometer completely, so the thermometer will touch the base of this beaker. So it will not record the temperature of ice. It will record the temperature of beaker. Okay, it will record the temperature of beaker. So remember, beta, thermometer should be 1/3 immersed. Okay, and the second precaution is when you are taking the reading of thermometer, so your eye contact should be perpendicular to the thermometer. All right, if you will keep your eye contact like this, so it means it will read the parallax error. Okay, it will have a parallax error. It will give us incorrect reading. So this position is incorrect. Always better remember that Measuring instrument should read perpendicular. All right, we should read the measuring instrument perpendicular to the line of sight. Otherwise, it will record parallax error. Are you understanding these precautions, students? Okay. Now, how we will perform this experiment, beta? Initially, burner is off. We have taken out the crushed ice from the refrigerator and we will record its initial temperature. Okay. So its initial temperature must be -15 or -17 degrees Celsius. Okay. So obviously we have to note down the reading of initial temperature somewhere. So I will make one observation table. Okay. अब देखिए, if this question will ask in ATP, so in ATP examiner will ask you to make observation table. अब क्वेश्चन ये कि हाउ शुड आई मेक ऑब्जर्वेशन टेबल इफ आई एम नॉट परफॉर्मिंग दिस एक्सपेरिमेंट. तो देखिए बेटा, इफ दिस क्वेश्चन will come in ATP. ATP means alternative to practical. So just you have to draw the observation table like this. You have to write down the column headings only with proper unit. Column heading means which two variables. Yes, Inaya. Which two variables you are taking to perform this experiment. So the first variable I am taking is time. You can take time in minutes or in seconds. And the second variable I am taking here is temperature in degree Celsius. बस अब आपको इसके अंदर कुछ भी फिल नहीं करना है, सिर्फ कॉलम हेडिंग्स लिखनी है आपको. इन कॉलम हेडिंग्स को लिखना, ऑब्जर्वेशन टेबल ड्रॉ करना है. यू विल गेट 2 मार्क्स. 2 मार्क्स का क्वेश्चन आता है ये. ठीक है. नाउ लेकिन अभी मैं आपको समझा रही हूँ तो मैं यहाँ पे रीडिंग्स फिल करूंगी. ठीक है. अच्छा, what they are asking, what we are doing here, we have taken the crushed ice, put it into beaker, immerse the thermometer into the crushed ice, and we will record the initial temperature. When the time is 0, initial temperature is -17 or -15 degrees Celsius. Okay. So the next step is we will turn on this burner and we will turn on the stopwatch as well. ठीक है, हम बर्नर ऑन करेंगे और स्टॉपवॉच ऑन करेंगे. एंड वी विल रिकॉर्ड द temperature of ice with thermometer after every minute. Okay. We have turned on the beaker, oh, sorry, burner. We have turned on the stopwatch. Now we will record the temperature of thermometer after every minute, like after 1 minute, 2 minutes, 3 minutes, 4. So temperature will start to decrease. ठीक है. -17, -15, -12, -10, -6, and then the temperature will reach to 0. ठीक है. So as the temperature will reach to 0, the temperature will not change for few minutes. अब देखें, टाइम तो चल रहा है बट टेम्परेचर चेंज नहीं हो रहा काफी देर तक. आफ्टर एवरी मिनट आई विल रिकॉर्ड द टेम्परेचर एंड इट विल गिव मी 0 डिग्री सेल्सियस, 0 डिग्री सेल्सियस, 0 डिग्री सेल्सियस. ठीक है. बट आफ्टर फ्यू मिनट्स then the temperature will start to increase like 1 degree, 2 degree, 5 degree, 7 degree, 10 degree, and so on. ठीक है. So basically, why the temperature is not changing here? What is the reason? So look at here, students. Look at this graph. Obviously, we are performing this experiment, so we have to see, draw the graph as well to check the relation between time and temperature. Okay. So look at this graph very carefully, beta. This graph is very important. Okay. You can see on x-axis, we are taking time in minutes. We are taking temperature in Celsius on y-axis. All right. This curve is called basically heating curve of water. Heating curve of water. So now you can see, beta, the crushed ice temperature is initially -15 degrees Celsius. -15 या -17 हो सकता है. ठीक है. And when we have started the burner, so the temperature of ice will start to decrease. All right. Temperature of ice will start to decrease. So from at point P, ice is in the solid state. Assalamu alaikum, Vania. Vania, we are discussing the experiment melting point of ice, and right now we are discussing the heating curve of water. Okay. So this is the, so basically at this position, the ice is in the solid state and we are continuously supplying heat energy to the ice with the burner. So you can see the ice temperature will start to decrease, not decrease, basically increase. Ice decrease तो और minus में जाएगा, ठीक है? The ice temperature will start to increase, but still from P to Q, ice is in the solid state. इसका मतलब it is not melting, it is in the solid state. But you can see as the ice will reach, that ice temperature will reach 0 degrees Celsius, which is the melting point of ice basically. So now the temperature will stop for few minutes. You can see the temperature will stop for few minutes from Q to R. So this state is called fuse state. ये जो state है ना Q से लेकर R तक, ये कहलाती है fuse state. फ्यूज स्टेट का मतलब ये है कि इसमें आइस ना तो कंप्लीटली सॉलिड स्टेट में है, ना ही कंप्लीटली लिक्विड स्टेट में है. बेसिकली आइस इज इन द फॉर्म ऑफ सॉलिड प्लस लिक्विड स्टेट. It is a mixture of ice and water. What is the reason? Because this is the transition state between solid to liquid. This is the transition state, students. And this is the state where the ice will start to melt. This is the melting state of ice. ये melting state नहीं है बेटा. This is the melting state of ice. And you can see the temperature is constant. Temperature is not changing, so that's why we say during melting temperature will not change, temperature will remain constant. Definition ही यही है melting की, ठीक है? During melting temperature will remain constant. So you can see here temperature is not changing. This is the melting state from Q to R. अब क्वेश्चन ये आएगा एग्जाम में आपके कि why temperature is not changing between Q to R. तो यहाँ पे आप ये कह सकते हैं कि these are the atoms of solid which are tightly packed, they are absorbing heat energy. So when they are absorbing heat energy, they will start to vibrate. And जब ये vibrate करेंगे तो their bonds will start to break. तो basically ये जो energy absorb कर रही है ना आइस, ये energy bonds को break करने में यूज हो रही है. ठीक है, देखिए हम एनर्जी एब्जॉर्ब करेंगे तो टेम्परेचर इंक्रीज होना चाहिए. यहाँ पे एनर्जी एब्जॉर्ब करके आइस टेम्परेचर इंक्रीज कर रही है क्योंकि काइनेटिक एनर्जी बढ़ रही है. यहाँ पे काइनेटिक एनर्जी नहीं बढ़ेगी, यहाँ पर एब्जॉर्ब एनर्जी इज बेसिकली परफॉर्मिंग द वर्क टू ब्रेक द बॉन्ड बिटवीन द आइस मॉलिक्यूल्स. तो ये एनर्जी जो हम इसको दे रहे हैं आइस को, ये एनर्जी क्या काम कर रही है बेटा? बॉन्ड्स को ब्रेक कर रही है. टेम्परेचर नहीं बढ़ा रही, बॉन्ड्स ब्रेक कर रही है. So when the bonds are breaking, so it means that now the ice molecules will no longer at the fixed position. They will start to move away from each other. ये एक दूसरे से अवे जाएंगे. जैसे ही एक दूसरे से अवे जाएंगे, it means it is no longer in the solid state. Now the ice is converted into the liquid state. तो R के बाद से लेकर S तक आप देखें, this is the liquid state. और जैसे ये मेल्टिंग इसकी कंप्लीट हुई, मेल्ट हो गया लिक्विड, सो यू कैन सी द टेम्परेचर विल स्टार्ट टू इंक्रीज. तो इट मीन्स स्टूडेंट्स ड्यूरिंग मेल्टिंग which is the fusion state, which is the solid plus liquid state, the temperature will remain constant because energy absorbed by the ice is used to break the bond. Molecules are moving away. So basically the heat energy is performing a work here to break the bond between the solid particles. Then after R, it is converted into the liquid state and its temperature will start to increase. Clear, students? Are you understanding this heating curve, that why the temperature do not change during melting? Are you understanding this thing, students? अब ये कब तक इसका टेम्परेचर इंक्रीज होता रहेगा? जब तक ये बॉयल नहीं हो जाता. तो इट विल रीच द बॉइलिंग पॉइंट. ओके, सो नाउ आई एम एक्सप्लेनिंग यू दिस हीटिंग कर्व अगेन. You can see this is the not complete, this is a heating curve of water, melting heating curve of water. So you can see this is the temperature which is in -degree Celsius. So from A to B, ice is in the solid state. It is absorbing the heat energy. All right, its ice molecules are absorbing the heat energy and they will start to vibrate on their mean position. But still, the ice is in the solid state. At it will reach point C, sorry, point B. So now this is the point which is called the melting point of ice. Uh-oh. So now you can see they are saying during the melting process, the temperature of the substance remains constant, even though the heating continues. We are continuously supplying the heat energy, but still the temperature is not changing because this temperature or this energy is used by the solid molecules to break or to overcome the force of attraction between them. All right. Then after C, the solid is completely melted and now it is converted into the liquid state. So you can see its temperature is increasing. All right, everyone. Is it clear to you that what is the heating curve of water? Are you understanding better? This topic is important. I'm telling you again and again, especially this state from B to C. All right, question can be asked. Many questions can be asked for this state that why temperature is not changing here. Any question here, students? Then are you understanding, beta? Ahmed, Zurez, Inaya. Zurez is not here in the class. Yeah, he is here. Sorry, beta. Okay. Yes, beta. All right. So now, students, this was the heating curve of water. Okay, I'm showing you the experiment again. All right, this is the simple beaker and the crushed ice is in the beaker to make contact with the thermometer. All right, initially the crushed ice temperature is minus 17 or minus 15 degrees Celsius. Okay, so now burner is off and we will record the initial temperature. And after recording the initial temperature, we will turn on the beaker and we will turn on the stopwatch as well. Okay, so that the temperature of the ice will start to increase and we will record the temperature of ice by using the thermometer. Okay, so we can draw the curve between the temperature and time. So we are getting this type of heating curve. Okay, any confusion here, students? I can show you the complete heating curve of water. uh, uh, okay, so you can see this is the complete heating curve of water. Okay, this is the diagram which is showing the complete heating curve. Okay, so this is the basically solid state of ice. All right, this is the solid state of ice. At this state, the ice is melting, solid plus liquid state. Okay, at this state, the ice is melting. Okay, ice is absorbing the heat energy. All right, and after this point, the ice is converted into the liquid, so its temperature will start to increase. All right, and it will keep increasing till it will reach the boiling point. What is the boiling point of water? What is the boiling point of water, students? Okay, exactly. The boiling point of water is 100 degrees Celsius. So it means that the temperature will reach till the water will get 100 degrees Celsius. Well done, Suresh. So at this point, again, from this state to that state, the water is in the liquid state. But as the water will reach at this point, beta, now the liquid will start to convert into the gaseous state. Now it means the boiling will occur at this state. Boiling. All right, boiling will occur at this state. So again, this is a fuse state. Fuse means liquid plus gas. Liquid plus gas. So again, student, the liquid molecules force of attraction is stronger as compared to gases. So now they will again absorb the heat energy. All right, but their temperature is not changing. Heat is continuously supplying, but its temperature is not changing here. What is the reason? Again, the liquid molecules will use this energy to break bond between them. Okay, liquid molecules will use this energy to break bonds between them. And once the force of attraction becomes weaker between the liquid molecules, bonds are continuously beta breaking. So now the gas molecules will, liquid molecules will move away from each other like this, and the liquid is completely converted into the gas state. So you can see at this state, the water is converted into the gas, which is steam, and then its temperature will increase. So it means, the student, remember this thing: during melting and during boiling, temperature will remain constant. Okay, I'm repeating: during melting and during boiling, temperature will remain constant. So melting is the process in which solid is converted into liquid without change in temperature. Similarly, beta, boiling is the process in which liquid is converted into gas without change in temperature. All right, students, is it clear to you? Any confusion here? Any confusion here, students? Acha. Now, students, I will introduce one new term here. The new term name is latent heat. Latent heat. What does it mean by latent heat? देखिए बेटा, these are the two transition states. Okay, these are the two transition states. The first transition state is melting, where the solid is absorbing the heat energy to convert itself into the liquid. So in this state, during this state, heat energy, देखिए वानिया बेटा, latent heat formula and calculation has been removed from your syllabus, but latent heat definition is a part of your syllabus. Okay, latent heat, I can show you beta, latent heat definition is a part of your syllabus. All right, just give me 1 minute. That's why I'm discussing only the definition, not the formula. Okay, formula calculation has been excluded, but still beta, the definition is a part of your syllabus in O levels or in IGCSE as well. Okay. This is the difference between boiling and evaporation. Evaporation, I'm just trying to figure out the definition of latent heat. I just go through the recent syllabus, and in which they have mentioned here that the latent heat of definition is a part of your syllabus. 1 minute. Let me check the O level syllabus as well. Yeah, this one. This is the point. I read that point, so that's why I'm discussing latent heat as the energy required to change the state of a substance. So just you have to memorize the definition, student. Definition is a part of your syllabus, okay? But not the formula and calculation. All right? Okay, so what is latent heat, beta? Latent heat is the energy absorbed during the change of state. All right. Latent heat is the energy absorbed during the change of state. All right. So now you can see at this state, the solid is converting into the liquid. So heat energy absorbed by the solid to convert itself into the liquid. This state is called, this energy absorbed by the solid is called latent heat of fusion. Okay, latent heat of fusion. All right, students. And at this state, the heat energy absorbed by the liquid to convert itself into gas. देखिए बेटा, not in this state, only in this transition state, the heat energy absorbed by the liquid to convert itself into the gas. This energy is called latent heat of vaporization. All right, latent heat of vaporization. Clear, students? So this energy, when the solid is converting into the liquid, is latent heat of fusion. And this energy, when the liquid is converting into gas, is latent heat of vaporization. Is it clear to you, students? So I'm just showing you the definition of latent heat, so you can write down. Latent heat is the heat required to convert a solid into liquid or liquid into vapors. Vapors means gas. That is defined as latent heat. So write down this definition only, beta. Latent heat is the energy or heat required to convert a solid into liquid or liquid into gas. Clear? Done, everyone? Okay, now we will solve some past paper questions, student, related to this topic. Okay, now you can see question number 39. Some ice cubes are taken from a deep freeze and placed in a metal container. All right. The container is heated at a constant rate and reading of temperature and time are taken. So this is the same thing, same experiment which I discussed with you. This is the complete heating curve of water. The results are recorded on a graph. Which temperature correspond to 0 degrees Celsius? 0 degrees Celsius. Which temperature is 0 degrees Celsius? So students, 0 degree Celsius is the melting point of ice. So which one is the right answer? Okay, Inaya and Hafsa are saying C. Vania is saying C. What about other students? Aiza, Shamin, Zerlish. Okay, good Zen. Well done, everyone. Z is the right answer. Sorry, C is the right answer. All right. C is the point which is showing that the melting state of ice. At this state, the ice is melting, and the energy absorbed during this state is called latent heat of fusion. Okay. Now look at the next question. In the next question, question number 11, they are saying thermal energy is transferred to a solid. First, it melts and then it boils to produce a gas. Which statement about the temperature is correct? Yes, student. In option A, they are saying when melting and boiling, temperature does not change. When melting and boiling, the temperature increases. When melting, the temperature increases, but when boiling, the temperature stays same. And in D, they are saying when melting, the temperature stays same, but when boiling, the temperature increases. So yes, so student, which is the right answer? Okay, most of the students are saying A. So well done, everyone. A is the right answer. That when melting and boiling, these are the two processes during which the temperature will not change. Temperature will remain same during melting and boiling. Good, everyone. A is the right answer. Now look at the question number 19. Ice at minus 10 degrees Celsius is heated until it is at